All right, everyone, let's go ahead and look at the problems that we have here. These are a few concepts being applied to these problems. These are just basic vectors, and we're going to use these for arithmetic to solve for a couple of values. So let's see. So we see that over here, this side is in rectangular, and we see over here, this is in phasor. So our first step, they want us to convert to phasor. So to convert to phasor, what we're going to have to do is find the it's more of a z value. We get that by doing square root sum of the squares of those values. Then we also need to find the theta. We'll get that from tangent inverse y over x. Just need to make sure. Okay, so doing that, what we'll need to do is solve for z1 first. This will be square root of 6 squared plus 3 squared. 6 squared plus 3 squared. Okay. This will give us 6.708. Then our theta will just be tangent inverse of that. 6 over 3. Tangent inverse 6. Mode 3. Sorry, it should be 3 over 6. 3 divided by 6. Okay, and that'll give us 26.56 degrees. So then just writing that on the side here, z1 is equal to 6.708 at 26.56 degrees. We're going to repeat this for these next three here. So square root sum of the squares. We'll get 3 squared plus negative 2 squared. Yep. And that'll give us 3.605 theta tangent inverse. It's y over x. So y is negative 2, x it's 3. That gives us negative 33.69 degrees. So therefore z2 is 3 points. We're going to do 6.1 and negative 33.69 degrees. For this last one here, notice we have 0. So 5 squared plus 0 squared just give us 5. 0 doesn't do anything for us. So then we'll have theta is equal to tangent inverse 0 divided by 5. That'll give us an angle of 0 degrees. So Z3 is 5 at 0 degrees. So this is that's how to convert from rectangular to polar. Now let's look at phasor. Now they want us to convert to rectangular. So to convert to rectangular, what we're going to do is z is going to be equal to so I'll call that Vm cosine theta plus j Vm sine of theta. So Z4, what this would be is 6 cosine of 70 plus 6 sine of 70 degrees. So if we write that out, you get 2.05 for the real part. Then we'll get 5.64 for the imaginary part. That's all we're doing. So Z5 would be 4 cosine negative 25 plus 4 sine negative 25. So Z5 would be equal to 3.63 plus and see it'll be notice there's a negative angle there, so the negative angle is going to give us a negative j value here, negative 1.69. Then Z6 will just be 2 cosine theta plus 2 sine. It's going to be 127. 127. Should be J right there. This is Z of 6. Negative 1.2 plus J. Okay. Then that'll be 1.59. Right. That's all we're doing, just converting these back and forth. And you might be wondering, okay, how do we get negative and positive values? We'll just kind of look at this. Remember, that is an angle. So it's take this for example. We'll do Z6 real quick. So Z of 6. Where this would be X and this would be Y. So if we were to take, so we'll do 127 degrees roughly. Then let's say that's Z6. Okay. So what this is saying is that for the real part, we're over here in the negative X. For the imaginary parts, we're up here in the positive Y. Okay. So all it is just vector components. So negative X and then positive Y. And it's helpful to use that angle to make sure these make sense. So you should have a negative X and then a positive Y. Yep. So that's just all I'm going to do for this video. Next video, I'm going to clean some of this up so that we have just a cleaner table, because we are going to be doing operations in just a bit. Okay, I'll see you there.